Now let's extend what we've learned to deal with when we have negative exponents either in the numerator or the denominator. Basic rule is when you see a negative exponent in the denominator, stick it in the denominator. So this will become 4 to the positive 3 in the denominator. What do you do if you have a negative exponent in the denominator? Put that up on the top shelf. So this becomes 5 squared on the top shelf. So to eliminate a negative exponent, put the base on the other shelf to make the exponent positive. Then from here you can reduce it down. 5 squared divided, that means what is that? 25 divided by 4, 1664. There you go. Let's look at 3/4 to the negative 2. Now this one's kind of hidden in a little bit. First of all, we might want to split up the exponents. So this is 3 to the negative 2 over 4 to the negative 2. Then from there, let's take the bases, put on the opposite shelves to make the exponents positive. So 3 to the negative 2 in the numerator becomes 3 to the positive 2 in the denominator. Then likewise, 4 to the negative 2 in the denominator, put that on the top shelf. That becomes 4 to the positive 2 in the numerator. And then just do your calculation from there, which makes it a 6/9. Now notice what really went on here too is I basically flip-flopped the 4 and a 3. So 3 to the 4 to the negative 2 was the same thing as flipping the guts and making the exponent positive. It wasn't a big stretch here. If you understood what's happening here, then you kind of understand why that was something that was noticeable. 1 over, I want to be careful writing this down right, 4x to the negative 3. This one might trip some of us up. So let's be careful here. What is the base? The base is only the x. So x to the negative 3 in the denominator becomes x to the positive 3 in the numerator. The 4 doesn't move. The 4 is not part of the base, so I leave the 4 down there. And this 1, the 1 is still up here, but if there's another term, the 1 is understood to be part of it, so I don't need to write the 1. You all right with that one? Let's look at one more here. X to the negative 5th divided by x to the negative 1, I believe. A couple of ways we can look at this. First of all, let's just go ahead and create a problem that has positive exponents. So I'd have x to the positive 1 on top, and on the bottom I have x to the 5th. Then how do we reduce that? Well, that becomes x to the 1 minus a 5, or x to the positive 4, or x to the negative 4. And then from there, really to make that positive, since we need to have in reduced terms a positive exponent, that becomes 1 over x to the 4th. So it kind of took a couple of skips and hops and jumps to kind of go through this process right here to reduce that one. But I hope you notice that every skip, hop, or jump I took was something based on a rule that we've already discovered.